Hello everyone. In this video, we'll see how to create an asynchronous stream of data using async stream in Swift. Async stream conforms to async sequence, so it's an easy and convenient way to create async sequences without the need to manually implement an asynchronous iterator. I put a link in description to read more about async sequences and how to create a custom asynchronous iterator. To begin with, I'll write a simple insertion sort so we can see the process of this algorithm over time using an async stream. You can find the link in description with more details about the insertion sort, but here's a quick refresher. The algorithm assumes the first item in the array as sorted and it starts from the second item. If it's smaller than the first item, it moves it to the right. Otherwise, it stays. Similarly, it iterates through the array and keeps moving elements to the right to find the correct spot for each element. After that, I will use SwiftUI charts to visualize this process. So now that we have a plan, let's jump in. I start by creating an algorithm object and add the insertion sort method. This function has two inputs. First is the initial array, and the second one is the instruction of how to sort it. In this case, ascending or descending. And as the return type, we want to return an async stream. Now we start to write the body of our function. We start by returning an async stream with the type of integer. In async stream block, we have access to a continuation, which can be used to emit new values or signal the end of the stream. And now here, I can start writing the algorithm itself. Since we want to see the progress of the algorithm, after each swap, we want to emit a new value in this stream. And once the sort is done, we want to finish this stream. And because this is an asynchronous work, I need to wrap it in a task block. Okay, so cool. And this is how it looks if I try to sort an array and print the result. But this is not exactly what we want. Let's visualize this process using SwiftUI charts. I start by creating a new SwiftUI view, and here I will initialize the algorithm object that we just created. We also need an array of numbers to sort. Creating a chart is pretty straightforward. I start by adding a chart view and then use the indices and the values of our array as the x and y values. I also need to import the charts. And in our case, we will use the bar mark. And then I will add a button to start the sorting process. And for the sorting, we want to go with the ascending order. Here I can start to use this stream to get the values and update the data array. And because this work needs to be in asynchronous context, I need to wrap it in a task block. Here I'm adding a loop to iterate through the values of this stream, and whenever a new data is available, we will update the data. And now I will add the label for our button. Our view is ready. Now I will add a preview provider for this so we can see it in previews. Alright, now if I run the preview, we should have everything ready. So cool, right? Thanks to our API, now it's easy to sort it in descending order as well. This is really cool, but we can do more. We can track where the algorithm is looking at and where the swaps are happening. To do that, let's update the stream to return the indexes of the traverse. We start by updating the async stream return type, and in the yield, we return two other values. We are done here. Let's go back to the view and update the new values. We need to add two other variables. One for the value of I and one for the swapped value. For adding the color to the chart, let's start by implementing a new function. What we can do here is, for example, if the current value equals the value of I, we return the color black. And if the value equals the swap value, we return the color of green. Otherwise, we just return the color of blue. With this function in place, now we can update our chart with the foreground color. Okay, everything is building. I also need to update the loop to update the new variables that we just created. Okay, everything builds, and now I can run the preview again. Oops, it seems I accidentally removed the delay that we added here. So I will add the delay again. Okay, so if I run this again, we can see how the algorithm is working and how the values are being sorted. Alright, much better now. And that was it for this video. Please let me know if you have any questions, and until next time.